Hello. Okay, very exciting once again, because I left the, or I trained a network that looks like this again, with the tweaks that we made last time so that it would learn for longer. And the results are very cool. So if I ran this also between streams. So what I'm doing is I'm loading the network that I trained yesterday, and then I'm taking our training data and seeing how much of the training data does it get correct. We know that it gets a little over 50% of the data that it's never seen correct, but the data that it was trained on, it's basically memorized 99.5% of the dialogue of Final Fantasy VII. So if I put as my prompt any text that actually comes from the game, it's going to start spitting out the rest of the dialogue in the game. So Barrett, come on, newcomer, follow me. Biggs, wow, you used to be in Soldier, all right. Not every day you find one in a group like Avalanche. So it's literally, it memorized the whole text of the game, and it's not doing it perfectly. There's still a 0.5 error. I think some of that is, or possibly all of it, I don't actually know, is coming from the size of the context window. So it only knows 20 characters at a time. So maybe characters are ambiguous. Like if someone says, I live in sector, maybe one character says sector 6 and one character says sector 7, so it can't be right 100% of the time. And so it jumps around in the dialogue. At some point it skips ahead. Like here Cloud says, I don't care what it is, I'm gonna bust him up. That's a combination of two different lines. This is, the first one is, I don't care what your names are. And then if I just search for don't care what, later on someone says, I don't care what it is. So how many, yeah, this is 20 characters. No, this is 19. Wait, if I include if I include the colon, how about? That's 20 characters. So it actually can't tell the difference between these two lines. And that's why it jumped ahead, because both would be completely valid next characters. Okay, so that's very cool. But our goal is not to just regurgitate text, because if I give a prompt, hello, my name is, if I give a prompt that's not part of the text, it'll just find some part of the text to continue it. Hello, my name is apostrophe end of the might us deshin out of Avalanche. So this is good in the sense that it's not just quoting the game. It's, the game doesn't say deshin for, you know. But at some point it snaps back into the game and it continues based on actual dialogue, which is not what we want. Or it's, you know, it's debatable if that's what we want. So here's my goals for the stream, and I know we're not going to get to finish all of this. So we'll see how far we get. But the first is to add a temperature to our Softmax. So remember, Softmax is our output layer. And it's basically taking it's basically making a probability distribution over the characters that it could pick. And then we're using argmax. So we're saying actually pick the character that has the highest probability. If instead of using argmax, we used a random choice that was weighted by the probabilities, then we'd be less likely to verbatim quote the game, because we wouldn't always pick the most likely next letter. We would pick among the most likely next letters. And then if it's still quoting too much, we can just increase the temperature. So increasing the temperature basically means boosting the probability of the non-max choices in the softmax. And the formula for it is just you divide the input to the softmax by a temperature just being a number. And that gives you the smoothing thing that we're talking about. So softmax temperature. So this is softmax, and then here beta is a temperature. So you just multiply the input to softmax by beta, and that scales the output. So let's do that. The other cool thing about that is we don't need to train again. We can use the exact same network that we already have, but just instead of taking the argmax, take a weighted choice. So what's a good way to do this? So we can take this guy. This is like the output. And then instead of taking the argmax of the output, I want to take, so maybe we can call this weights. I want, like, do I have random in here? Import random. Random.choice. How do you do that? Python random choice weighted. You can pass weights. And then you can say how many you want. I only want one. So I can use choice. If choice lets you do that, does choice take... it's hard to inspect. It doesn't look like choice lets you choose. So we'll just do choices. The choices are basically range len of weights. The weights are weights, and k equals 1. So this means the first weight is the number 0, the second weight is the number 1, etc. I don't know if it's going to let me do that or if I have to cast this to a list. Let's find out. But this gives us a like encoded a number output. So does this work? Oh, let's comment out this part because I don't need to run the validation, and that took like 10 minutes last time. Hello. What happened here? I don't know what that was. Let's change this to be down to 100 characters to predict. Cloud I. It's just predicting a bunch of spaces or new lines. Oh, because I shouldn't be doing the argmax anymore. If I were doing, okay, so if I were doing argmax, this would be weights. But I'm not doing argmax anymore. So this is just decode num. List indices must be integers or slices. What is num? Print num. It's a list with the number 27 in it. Oh, because I did choices k equals 1, so just give me the first element of that. Okay. Let's get rid of our print here. Okay. And now let's do the test from before, where we just grab the first line of the dialogue and see if it regurgitates the rest of it. Come on, newcomer, but Xreet, Eris, you're up, and baby, and receive weird at Ank the Barret. But we all do this. Interesting. So now I should be able to tweak the temperature and get closer to an argmax and farther from an argmax. To and see like what's a good temperature where it is not purely quoting the text, but it's still saying stuff that's very related to the text. So where would I put that? It's I think it would be when I apply. It's in the oh, I wonder if this is going to be hard to do then. So it's basically in this function. So if I go all the way to my neurons, I would want to replace z here with z times temperature. However, the way that I'm loading my network makes that tricky. Not data load, but network load. Because the neurons are being pickled, so I can't change the code of them. I mean, it is weird to be pickling the neurons, because I actually only want to pickle the fact that it is a softmax, not the implementation of the softmax. So I could change the way I load. I wonder if I could just like push it through another softmax. I kind of think I could. Because the softmax has the properties that I want, where it'll preserve the order of the relative like size of the, not the relative sizes, but like the fact that they're in a certain order, and it'll scale them properly. So I could just push them through another softmax with a temperature of my choosing here. What would the other way of doing it be? It would be like, when you load, don't just grab the neurons from what you loaded, grab the current definition. I don't know, that's kind of weird. Let's see if we can just push this through another softmax. So weights equals softmax dot f weights. How does it work? I just want to multiply by temperature. So weights times temperature. Temperature equals 1. Let's start with that. Though one is not actually going to make it. This is still going to have an effect even with the temperature of 1, because I'm pushing it through a second softmax layer, so that's going to tend to max it further, I think. Which means I think this will be closer to quoting verbatim, if my intuition is right here. So let's grab this first line of dialogue. Not even close. Okay. Why is it so wrong? Isn't that weird? I kind of want to print weights before and after, then exit. Everything got evened out by a lot when I put it through a second softmax. So what if I make the temperature be really, really small? Then everything gets smoothed out a lot. And what if I make the temperature be really, really big? That also smooths everything out. No, there were overflows, so maybe that's too big. Well, okay, actually... Oh, I can't change this code anymore because I am loading the definition. I was going to say I should use the more numerically stable version of Softmax if I'm going to be multiplying by huge numbers, but it's too late. It's really not what I expected to see. I don't know why this is doing this. I would have thought there's some temperature where it's like I didn't put it through the softmax. Okay, so pushing it through Softmax twice is not working, and I don't really know why. This is the version that's working, yeah. Okay. So how do I fix this? So I'm saving the number of neurons. I'm saving the neurons. But here what I want to do is like don't load the definition of the neuron, load the fact that it's that neuron, and then load the definition from my own from the code instead of from the saved file. I don't know. The other thing I'm thinking is maybe I should just not apply the final softmax. When doing .apply so that I can control the temperature from outside. Or I guess I could also just do like this. Apply, comma, temperature. equals 1. And then on the last one, apply the temperature. So this is like z equals this. If we're on the last one, how do I check that? I'd have to change this to be like I, comma this in enumerate. That's kind of weird. Can I just do if n equals self.neurons like that? Times temperature. Or here. Z equals, or times equals temperature. Will that do it? So obviously this should have the same output as before, and it didn't. Wait, why is it not deterministic? Oh, because I'm doing a random choice, obviously. I kind of want to seed the randomness. Can I do that? Yeah, I can. Random.seed equals, or random.seed 0. So now will it be deterministic? Hello. And then I try again. Hello. Yeah, that's the same thing. Okay. So now I want to try different temperatures. So apply temperature equals 10. Total of weights must be finite. How did my weights end up infinite? What? Maybe 10 is just too big. Huh. Print weights. Print weights. Exit. So, oh. Okay, just print the weights after they get defined then. Not a number. Okay, so this 1.1 pushed it to like almost infinitely 1 here and 0 elsewhere. 1.0 is also doing that. surely that means it already was extremely certain what the next character should be. But I guess... Okay, so is 1.1 gonna work then? Hello. And then if I quote the dialogue... Okay. And then why don't we say, give me 1,000 characters. So basically 1.1 looks like it's saying, like basically just always return the most. No, it's still a little bit less than the argmax, or like it's a little bit different than the argmax. This is interesting also. We managed to break out of a loop because at some point the random choice is changed, or like it chooses a different random choice. Okay. So my hope that we could get a temperature that would be the same as argmax is not looking good. I mean, you know what? We probably would if I could change this to use the numerically stable version, but then we'll have to train it again. Or we'll have to change, we'd have to like fix our save file or not load from our save file. I do want to do this though. So is this Grandpa and Grandma? I'm curious how closely is it sticking? Yeah, this whole line is quoted. No, it changes at some point. But after the Shinra built that city above, the sun stopped shining here, and the water got polluted. I was raised on that story and hate Shinra so much. Never mind, it didn't change. So what if we turn the temperature down? 0.9. It's more... It's weirder. Which is cool. Maybe we need 0.95 to make sure that it's at least using words. I can't tell, like this text looks really weird, but the text of the game is also really weird. If they, oh my god, come on. If they were really from Soldier, they would be doing something about all this. The trick to being a real materia. So it switched from man to materia. Now a thing. That's nowhere. A thing. Yeah, a thing is not written anywhere. And then I'm moving on a deal right now. I'm moving on ahead is one line, and I'm on a deal. On a deal is not anywhere. Oh, I'm moving on. Yeah, on a deal. On a day exists, and deal on the right doesn't exist. So this is actually cool. It's saying stuff that's not totally pulled from the text, but also almost looks like it makes sense. Professor Hojo, that scary man says he wants to talk to you. That scary man. That's a line from the game. Choose anything. That's not a sentence. Anything in your... Okay. We was just a loticulated. This seems like a good balance, and it's pretty cool. So I think if we trained, maybe let's just do that right now. Let's train something with the trying to think if I would even be able to tell the difference. I think I would. So I'm training something. Oh wait, this is not going to be fast. Oh. And it's getting numerical issues. I don't think I changed anything about that. Change this. But apply is not even used during training, is it? It's used during validation. Oh, I applied temperature twice by accident. So I don't actually know what a good number is yet. 0.95, what does it look like when I'm not applying temperature twice? That's more random than before. That still seems very random. If temperature is 1, does it go back to not looking random? No, that's still random. One 1.1. It's getting worse, isn't it? Hard to say. 1.5? This looks less random. This looks more like dialogue. How high can I go now that it's now that I'm not doing it twice? Well, it let me do that. I guess now it can get stuck in loops. Cool. And then this test line, if I grab the first line of dialogue, we've tested this a few times. Yeah, now it's quoting the text. Mostly. So with like 100, are we back to same as if we weren't using a random distribution? Yes. This looks almost the same, if not exactly the same. It's not exactly the same, actually. 1,000? As the argmax version, I mean. But it's getting less and less random, so... Okay, bringing temperature up makes it closer to argmax. Temperature around 1. Is going to make it more creative. But that looks a little too weird for me. And then was 1.5 a good one? Now 1.5 is already like mostly just quoting the text. 1.1? It's still mostly the text. Well, I don't know actually. Wow, you used to be in Soldier. I'll tell you how much I know, and for free too. That's not the right line. I'll tell you how much I know. Yeah, that's another line from later. What if I make it... Like 1.0 actually seems like maybe that's the sweet spot. Like, there's a lot of gibberish, but there's not a lot of quoting the text, and it looks like English. Hello, my name is... received 0 gil. Yeah, that's not even a line. 0 gil. Yeah, you never received 0 gil. That's cool. All right, let's move on. We've been playing with this thing for long enough. I just want to make sure. Oh, I'm not importing NumPy anymore. Import NumPy as NP. That argmax would still work. That I didn't break that. Yeah. Oh, actually, and this looks like it is saying the same thing as having a temperature set to 1000. So, same as temperature equals 1000. So we don't need it anymore. Okay, let's move on. Softmax temperature, check. What are we doing next? So the implementation that I have for okay, all right. Let me motivate why these are the things I want to do next. Softmax inner layers, residual layers, and layer norm. If we take a look at the transformer architecture, the output, or there's more than one version of it. Let's look at the version. I think this is from the original Attention is All You Need paper. The output is a softmax layer. So we have that working. The layer right before that is a linear layer. We also have those. And I think that the way that we've defined our softmax, it's a softmax and a linear combined. Because our softmax is just a function that we run after multiplying by weights and adding biases, which is what linear means. So this part, we have it working. Feed forward just means a regular neural network. So we have these. Add and norm, we don't have. So add is referring to this kind of thing. It's also called skip connections or residual connections. It's when you add, you have a vector here, which was the output of this network. And to that vector, you add the input from over here. So this skips these layers. That's why it's called a skip connection. And gets added to here. And from what I've read, I think these are pretty easy to implement because the gradient, remember while you're doing your backward pass, you're keeping track of your gradients. The gradient here is the same as if you didn't have the addition here. The gradient here is the same as if you didn't have the addition. And then the gradient here is just the gradient from this way and the gradient from this way added together. So that should be pretty easy to do. So that's skip connections or add. Norm this is layer norm. I've read about how to do it. It's going to be tricky. I put that as last. We'll see if we can do the easier stuff first. And then I don't think this is written here anywhere, but the inside the multi-headed attention, there's softmax layers. So I wonder, I don't know where I would see that. Attention is all you need. Images. Here. See, there's a softmax inside the attention block. So we've already got softmax, but the softmax that we have only works as the output layer. It's not going to work in the middle of a network. And that's because our f prime here is kind of a lie. Our f prime, we're combining the cross entropy or log likelihood cost function with the f prime of the softmax together. So we're not calculating either of them. We're just calculating the combination of them. And like the combination of them ends up being 1, because that's why we like log likelihood, because it makes softmax have a really simple gradient. But if you're in the middle of the network, you can't just assume that you can't skip computing the derivative. So it's kind of like here with our sigmoids. We had a sigmoid for inside the network and a sigmoid with a different derivative if you're the output layer and you're using cross entropy. So what we need now is we need a softmax that can be used as an inner layer. Yeah, softmax inner layers. So let's do that now. Neurons, softmax. It's going to be the same as the other softmax. I wonder if I can even just say f equals softmax.f. Call this inner softmax. And this one is going to be different. So I'm not so good at the math, calculating the gradients myself. So I had some help from our friend Gemini to help me with calculating, or calculating how, or helping me figure out how to calculate these deltas. Where is it? For an inner softmax layer. So there's some stuff we're gonna have to change here, basically. It's not gonna be as simple as just changing the f prime function. The reason being, the way this was implemented, and I'm struggling to find where I'm even talking about here, back propagation. the way this was implemented, which I will find eventually here, delta. It assumes that the form is always going to be matrix times the last delta times the derivative of the activation function. But softmax is more than just an activation function. My understanding is the reason that this is not valid anymore is that softmax is not the output of one cell of the softmax output vector is not independent of other. I'm saying this really wrong. It's like I don't know how to say it because I don't really understand it either, honestly. But it's not as simple as this. I have to use a more complicated formula for delta for this layer. So this formula, I can't just change f prime. Although, now that I'm looking at it, I wonder if I could, because this here is this. W of the next layer times delta of the next layer. And this term shows up on both sides of here. So maybe I could reformulate this as W times delta times a thing, and then I could make my thing like work out properly here. I wonder if that's what I want to do. No, because I don't think that's going to work for other things. And I actually don't even know if that would work here, or if it just looks like you can factor it out. So what I kind of want to do is change the interface for neurons so that instead of just there, list of neuron. So that instead of just defining an f and an f prime, I have to define an f and a delta that takes the previous delta, like the deltas, the forward deltas, and calculates this. So where does f prime get used? Nowhere here. Only during backpropagation. And only to define a delta. So this is kind of a lie that this is times delta, because I'm abusing the fact that like the delta is going to end up being this. So then I'm saying the f prime is 1, even though it's not. It's just that the delta is going to end up being this. But the grad is more complicated and the f prime is more complicated. But they cancel out, kind of. Okay, so if I change neurons, instead of having an f prime, if they had a delta, then this would be delta L, delta of the last layer, equals self.neurons of the last layer dot delta and then I don't really know how to say what you are. You're the gradient of the input with respect to or I think I wrote this wrong, and you're the gradient of the loss function with respect to the input. It should be like that, right? So all right, I'm just going to do this the stupid way first because I'm having trouble thinking this through. I'm going to say you have a delta. Let's start with Softmax. You have an F. Let's get rid of inner Softmax. You have an F, you have an F prime for now, but we're going to deprecate F prime. You have a delta. I don't know what the signature for this is. I think you're returning an ND array. You're not taking Z, you're taking the future deltas. And this is a list of ND arrays. And then because I have not thought this through properly yet, I'm going to have some layers have a different way of getting a delta when they're the output layer. Because this combines the loss function with the delta. We're here, okay, so let's change the definition of neuron. Deltas, a list of this stuff, and did I call it output delta? Yeah. And output delta obviously shouldn't take any arguments. Maybe it'll need some argument, but I don't know what it is yet. Okay, so where is input? Okay, input can implement these as you're not supposed to call me. Okay. Then Softmax. Output delta is so this is output delta. And why don't we multiply this by that like before? This is weird. It needs to take the z probably. I think we're going to come back to this. Then this becomes delta equals self.neurons of -1 or j dot delta and what is it taking? It's taking the old delta, it's taking the weight matrix, and it's taking the weighted activation. I don't think it needs these, but the reason is I think we're mixing up I think we're mixing things up by having weights in our softmax. I think we'll be able to clean this up a little bit if we separate the linear layers from the activation functions and make those be two separate things. But I'm not sure how to do that yet, so I'm not going to do it yet. Okay, so delta, let's move this tab over here. Delta for softmax. Well, let's not break ReLU either. I'm basically going to return this, deltas W and Z. Just call this Z. I don't have a self.neurons, I just have a self. Actually, I don't even have a self because this is a static method. but it can be a class method. W is a ND array. Z is a ND array. So that's ReLU. Where's Softmax? Okay. So this is actually the same as the output delta for Softmax. Yeah. So at this point, I shouldn't have broken anything. I shouldn't have broken a network that has ReLUs in the middle and Softmax at the end. So let's see. Let's train a much smaller network, cars 10. Just make sure that it still kind of works. Output delta. So the output delta for Softmax, I said it should be this. It's only this, though, isn't it? I don't actually need any arguments, really. I can take Z just in case. Like that. Overflow. That's not good because we didn't used to have those. Oh, but that's because of the... That's because of the supposedly more stable Softmax implementation. Maybe there's a problem with how I'm doing it. So I'm expecting, yeah, I was about to say a number close to 50%. And I see a number close to 50%, which means it's able to learn and predict. We'll stop it after one more epoch and just make sure that the output looks somewhat reasonable. Okay, let's stop it there. Look at that. Looks reasonable to me. Okay, stop this. Continue trying to fix our mess here. So we're not using f prime anymore, we're just using delta. Let's get sigmoids working again. So output delta should take z's. Delta should take deltas, w, and z's. I just said z here. All right, the output could just take z because we know that there's not going to be more than one. The delta it takes deltas, w, and z. Fine, that's fine for now. I think we're gonna need to know more than this when we do things like skip layers, but we can add that later. Deltas, w, and z. Because delta also, you kind of only need the, well, you kind of only need the last one, but you also need the future ones if you're doing skip layers. So I'll leave, maybe that one's the only one that's going to be needed as a list. Okay, this is going to let us get rid of, no, it won't. So we'll be able to have sigmoid and sigmoid with cross entropy. Maybe we could rename this to sigmoid without cross entropy, or sigmoid with, what was the other one called? It was squared, something like that. Nielsen deep learning. Cross entropy, quadratic cost. Okay, so this one right now is sigmoid quadratic cost. This one is sigmoid cross entropy. I'm just going to rename this to just be sigmoid. Let's bring these guys in. So It's going to mean I can use the same thing in the inner and outer layers, which I wasn't able to do before because I depended on faking the F prime. So this is going to look the same as the ReLU one. Right here. So the output delta is going to be, how did I do it for the other one? Just 1. Whereas this one's going to look like this, right? I think that's right. And then with quadratic cost, they both look the same, I think. But I am getting a little confused. You would just return this. Because we're multiplying our output delta by this. Okay, so I think that's right. Let's change this back to sigmoid. I changed this to be called quadratic cost. Output delta is missing a required positional argument. Where? Is that because because I didn't say this was a class method? Okay, it's not throwing exceptions anymore, which means it's guaranteed to work. I think that's what that means. I'm expecting around 25%. Okay, 36%. That's better than I expected. Because sigmoids aren't as good as ReLUs on the inner layers, and they're not as good as Softmax on the outer layer. So let's stop that. Looks pretty good, actually. All things considered. I should be able to mix and match sigmoid Softmax. I have Softmax. Why is this? capital M. So this should be a little better than the last one, so a little better than 35%. %36% is a little better than 35%. I'll give you that. Okay. And then we should be able to do sigmoid with quadratic cost, which should be worse than 35%. So maybe this will be the 25% I was expecting. And I think this is the same issue. Class method. %, worse than I expected. But I did expect it to be bad, so yeah, everything is looking like it's working as expected. And then if I go back to ReLU, and Softmax, now this should work better. This should be closer to 45%. All right. We could fix our Tanch also. 45%, good. Beautiful. Let's fix the Tanch. So delta should be this. Output delta. I don't know if you can put Tanch as the output. How did I do that elsewhere? I guess I just multiplied by f prime. So this should be a quadratic cost. Quadratic cost. Okay, why do I have a pass here? Oh, because I have not implement inner softmax layer. But yeah, this is not really true. And so I think now I can get rid of the idea that you need an f prime. Not necessary. You just need the delta. And you don't need, output delta is a weird way to say it, but it's like delta combined with cost function. So and if I'm not mistaken, you could always just say your output delta is 1. It's like it is 1 for some choice of cost function, probably. Here, you are allowed to have ReLUs in the output. It would just be weird. So this would be with a quadratic cost. But is it true that there always is some cost function where the delta is 1? I wonder. Linear is not done yet. So let's add this. Okay. I don't want to test all these combinations, but because we never use any of them. The ones that I care about are working now, so let's move on. Okay, we're ready to implement this. Can I zoom in a little bit here? So or yeah, what is the correct signature? It would be this. So return delta, which is equal to activation of this layer. That's also called Z. No. That's also called X. Does that mean I need to pass X also? Which is X's of J. X is a np.nd array. So X, Hadamard product, and then this is the W times the next W times next delta, that's W is the next W. Deltas of -1 is the next delta. And that's what I'm doing elsewhere, right? Or deltas of 0 is the next delta? I guess I'm doing them in a different order. So if I grab this, I'm going to reuse this variable. So I'll just call it E. So E minus, I'm not sure if this is the right X either. I think it is, because the W is from J plus 1 and the A is from this J. So E minus something times a vector of 1s. So this is a vector, this is a dot product, right? Yeah. This is a vector, this is a dot product. So this is a number, and we're saying put that number in every position of a 1's vector. So np.1s, what do you take? I don't know how to read that. But you should be the same size as X, right? So is that how you do that? Do I not do this elsewhere? np.0. You can pass in a tuple, and I am doing that in a few places. So I think this should be okay. So this is the 1s. And that's multiplying this thing, which is E dot product. So np dot E and X. Okay. Okay. So I should be allowed to put a softmax in the middle of a network now. I don't know how to tell if it's working properly. So first thing is, did I break anything yet? I think maybe I did, because I'm passing. Okay, well, even more simple than that. This is just 1, and this is called log likelihood. And it's actually the same for cross entropy. Yeah, this is what I was worried about, that I'm passing X to everything now. So I need to say that you also take X. Z X np.nd array. Add that to all of these deltas. So you take X. Oops. You take X. You take X. You've already got X. You take X. And finally, you kind of don't need any arguments. You're not even going to work if we try to call you. But we can do this anyway. Class, args, quargs. No exceptions. We're expecting 45%. There it is. Very cool. It's cool that after a single epoch, it's able to say stuff like cloud and Shinra. Yeah, it's got a bunch of cloud, Yuffie. Very cool. That's Shissen. I agree, cloud. So if what we did worked, we should be able to have like a sigmoid after the softmax. The shapes are not aligned. Why does something have 50? That's odd. Well, I guess this is saying both E and X are matrices. Oh, of course they're matrices. 50 is my batch size. So I forgot that I'm passing this stuff in as matrix, like all my vectors are matrices so that I can parallelize across the batch. How do we, what's the equivalent of the dot product between matrices? Is it just a matrix multiplication? I'm trying to think. I think it. No, it can't be. It can't be. Also, np.dot would do a matrix multiplication if the two inputs were matrices. So how do I do this as a matrix? Like I could do this for each column separately. I don't know what to call a matrix made of vectors. Dot product on matrix of vectors. Yeah, I don't know how to say what I want. Yeah, dot product individual vectors within a matrix. Explicit looping. That's probably what I want. And it didn't give me an example of that. I click dive deeper and it's not diving deeper. It's not like an argument to dot product, right? How would I do it element wise? I would want to do like so E is a matrix, it's 87 by 50. X is a matrix, it's 87 by 50. I want to treat it as 50 separate dot products. And then my result will be a one by 50 vector. It'll be a 1 by 50, which I'm then going to be multiplying by a 87 by 50. That's right, though. That is what I want. Oh man, this is so confusing. Okay. N by M matrices dot product each column. numpy.sum. Okay. This might be what I want, actually. numpy.sum element-wise multiplication along axis 0. I think that sounds right. Because you end up doing a dot product on each thing. Oh, overflows. Oh, wait. Shapes are not aligned. But if it's an element-wise multiplication, isn't this what I want? NumPy Hadamard product. Yeah, you just... So then why would it say these are not aligned? Oh, wait, where's this dot product? Did I just not save or something? Oh, that was before. That was before the error. Okay. Clear. I was getting overflows though, which is a problem. What was overflowing though? This thing. So it makes me want to do the stable softmax, which for some reason has not been working. Stable softmax. I don't know what keep dims does. Okay. This person's just using max, which is not going to work because because my Z is a matrix, as I am remembering now. Yeah, I need numpy.max. I might need to specify the axis. I'm not sure. I wonder if axis equals -1 is the default. I don't know. Anyway, this has not been working and I don't know why. Maybe it's because I was missing the axis. No, invalid value encountered in subtract. Why though? What? I don't know. I don't get it. It seems like I'm doing it properly, and that gives me an error. This person's doing axis 1. I don't know which axis is which. Overflow, overflow, overflow. Invalid value. Yeah, and then it doesn't work when it overflows. I just do not understand why the one that's supposed to work better works worse. Although, like, they're both not working. So, okay. Why don't we try one thing at a time? Softmax is the output layer with the numerically stable version. Which I'm not using yet. I'm using the unstable version, and that works well for some reason. Then I want to switch to the other version. Which in theory should also work well, but in practice has not been working well. Okay, so there was no issues with this. Now we switch to this. And I'm gonna write it I was using regular sum, but that's not gonna work, right? Because this is a matrix. Why was that even working? I don't even know why that was working. All right, let me write this myself. So you've got, this is gonna be our last line, and then I just want minus m on both sides. And then m is just going to be this thing. That's the way that makes sense to me. I don't know why sum is working though. Invalid value encountered in divide. Which means we're dividing by 0 somewhere, right? Which means this is not going to work. But the whole thing is we're trying to prevent ourselves from dividing by 0 by subtracting the max element. Because what's the issue? It's that subtracting max of x from x leaves a vector that has only non-positive entries, ruling out overflow. And at least one element that is 0, ruling out a vanishing denominator. So this needs to be a NumPy sum, and I need to say which dimension it's in. I don't know what the point of keep dims is, so I'm going to take it out for now. And I haven't specified which dimension I'm talking about, so this NumPy sum shouldn't work. NumPy sum matrix. Okay, so I guess that's why keep dims is needed, and what if I say same axis as the other one? Okay, 0 and 1 mean column or row. So I actually want these to have different axes, I think. The max should be along the columns. Sums elements vertically. So give me the max for each column, and then give me the sum. No, these should both be column. This should be the sum of the column. Oh my god. Do we get it working? I wonder if we have it, if like our implementation is doing it in a weird way where other people usually have rows instead of columns or something, so all the code that we copied was wrong. Okay, so cancel that. Don't need this anymore. Let's just copy this. We didn't actually copy the code from there, but to avoid overflow and underflow. Then let's see now if we can have stuff after a softmax. We have a softmax in the middle of our network. No. Okay, so we're getting overflows again, but in a new place. So now we might need to use our knowledge of which axis is which. So E is an 87, 50 matrix. X is also E dot shape equals this. X dot shape is the same. Let's confirm that. Print E dot shape, X dot shape, and exit. Confirmed. So here's what we're trying to do. This is what we're trying to do. And actually, what's the issue we're running into? Overflow encountered in matmul. Neurons line 137. In the ReLU. Huh. Why is the error happening in the ReLU? Yeah, just a bunch of errors. The first one is line 152. That can't be right. There's nothing on line 152. Oh, network line 152. So how do you get a overflow in a matrix multiplication? Overflow encountered in matmul. It means we're getting a number that's way too big somewhere in there. So what's up with that? I don't know what's up with that. I guess I am not sure. I'm not sure where to start. The matrices are going to be really big. so I don't think I can just print them. I wonder if it's like if it's like weight initialization is the problem. The other thing I'm wondering here is, is this the same kind of softmax as I'm doing? Or is this just the softmax function and there shouldn't be any linear component to it? And I don't know. But could that even be the problem? I don't know. All right, I don't know if this could be the issue, but something I want to try is initializing smaller weights. Could it be that we're starting with weights that just blow up? I wonder if I would have to initialize them to be way smaller. Like, how about 10 times smaller than they are right now? A 1,000 times smaller, just to rule this out. Oh wait, this should be in parentheses. Wait, I'm not seeing errors. Okay. Softmax weight initialization. It is learning. We're not at 1%, which we would expect if it's not able to learn. So there's no reason why putting a softmax in the middle of the network should be better than what we were doing. So the fact that it just is able to do anything is good. Yeah, I don't know if we should have expected. I don't know what we should have expected, but better than nothing and worse than what we were doing before is what we would expect probably. Now, I'm also curious, now that we've screwed up our weight initialization, how bad does it work on a network architecture that used to work well? So this would have been 45% before we screwed up our weight initialization to be like almost 0 for all weights. Okay, so screwing up weight initialization makes it a little worse, but not very much worse. Okay, So I guess let's start thinking about weight initialization for a second. This person is saying for ReLU use he initialization, which is not one of the ones I wrote down. Uniform. We're using Lacune. And for Softmax, this person says use Xavier, which we have implemented here. So I'm curious if we just used Xavier for everything and went back to having Softmax in a intermediate layer, would we see overflows? Yes. Okay. So so this is not enough. So Lacune, they're saying is 1 over fan in. Which is what we were doing. I mean, we added this times 1,000 here, but this is Lacune. For he, they're saying that's 2 over fan in. I'm just curious. If we go back to this, does that help in any way? So 45 is what we've been doing with Lacune initialization. If we use he initialization, what does it look like? I mean, the other problem is this is messing with more than just the ReLUs. It's also messing with the Softmax. So it's not a good test. We maybe need to change our network to take different initializers for each layer. Wow, it looks like it may have actually helped. Interesting. Okay, stop that. So let's clean this up a little bit. First of all, Softmax interlayers, I think we have that working now. So check. Now we're going to take a little side quest to make weight initialization better. So let's make a touch initializers.py class initializer protocol from typing import protocol. You have a static method called Is this only for weights? Are we always okay with biases starting at 0? I wonder if we are. Static method called initialize, or we just call it weights. Init weights. Let's just call it initialize. Call these weight initializers. It just needs the dimension, right? Or what is network doing here? It needs 2 numbers. Fan in and fan out. I wonder actually, how would you do fan average? What does that mean? Oh, the average between fan in and fan out. Okay. Oh, but also, actually, this was something I missed. You can use uniform or normal distributions. Here I'm using a uniform. Default also says uniform or normal. Okay, so I'm just using uniform. So back to here. Basically just like this. We'll just call it fan in float, fan out, or these could be ints. And you return a numpy.nd array. Fan in, fan out, fan in. Import numpy as np. Does this look right? I think so. And then obviously this is this should just be ... This should be called a, we'll do a he. We'll do a lacoon. We'll do a chlorot. Or Xavier, I don't know who to credit. Xavier is 1 over fan in. Lacoon is, or wait, lacoon is 1 over fan in. Xavier is 1 over fan in plus fan out over 2. And he is 2 over fan in. So this is right now. We can have one that's like raise exception input layer. I can't just call it input because we already have a layer called that. No init. Okay, then here You take the dimension, you take the type, and you take the initializer. So Relu, we can use Lacoon, or we just found that Xavier seems to work better. No, he seems to work better. And then Softmax, we need to make our own tiny init. So you're supposed to be able to use what? Xavier. But that wasn't working for me. What worked was multiplying by a really small amount, or by basically having everything be 0, but let's see. So softmax, what did we say would work? What's the expected thing to work is Xavier? Yeah. Okay, and then you are taking a tuple and another type called weight initializer. I'm gonna put a comma here, not there, here. Yeah, you don't need the comma. So layer of 0 is still the sizes. Layer of 1 is still the neurons. And then initializers, list of weight initializers is 2. And then here, we can get rid of this stuff. Here you just take the correct initializer. Initializers. We'll add a I in enumerate this initializers of I. Whew, okay. So this should work possibly better than before. So 46 is what we were getting before. He has no attribute shape. That's true, but why are you trying to do that? Oh, did I accidentally switch? What did this say a second ago? y comma x. Y comma x, and then this needs to do dot initialize xy. Okay, so possibly this will be better than 46% because now we're initializing the softmax layer in a better way. $46. Not better than 46, but better than before we started using he initializers anyway. Okay. So what do I want to do now? I want to see if doing Xavier in the middle here, and then Xavier should be okay for this. I mean, we already know this is not going to work because we already tried something that was almost the same as this. The softmax neurons need to be, yeah, so that's not happy. And if I change this to tiny init, now this will work. It kind of, I mean, I don't really know. Oh, what? This was working before. Right? Like when we had the tiny... Oh, I guess we never... I guess I don't know which... It's possible that the issue wasn't in the softmax layer, that I needed to do a tiny init in one of the other layers for this to avoid overflows. So let's try the ReLU layer. And if that doesn't work, we'll try the sigmoid output layer. That does not look like it's working. So now we try the sigmoid output layer. That's not working either. What about when everything has tiny inits? Because this is what we thought was working earlier. No errors yet. Now I'm expecting to see 16%. There it is. Okay, we're doing some trial and error here. So what if the, don't don't do that. From initializers, import no init, tiny init, he, Xavier, and Lacoon, and don't erase those. Okay, what if only Relu is not tiny? Does that blow up? Yes, it does. What if, oops, where was I? So this is tiny. What if only Softmax is not tiny? Does that blow up? So far, so good. Okay, so everything but Softmax needs to be tiny. Try this one more time, even though I'm pretty sure we already tried this. This will blow up, right? Yeah. So everything but Softmax needs to be tiny. I don't get that. But, you know, I think I don't care. Maybe when we come back to having softmax in the attention layer, we'll have a better idea of how to initialize. Although I actually think that once we do that, we're not going to have weights for the softmax, because we're going to, at that point, we're going to split up linear and softmax. So this problem may just go away later. Okay, so what did we accomplish today? We moved initializers out so that you can initialize them separately for each layer. And that's about it. No, we did the temperature thing, which is very cool. So hopefully next time we're going to go for residual layers and layer norm. Residual layers I think will be easy. Layer norm I think will be hard. So let's see. See how it goes. But that's going to be it for now. Hopefully this was helpful.